We are iQS, Innovative Quantity Surveyors, and welcome to Richmond Park. This presentation takes a look at a civil engineering project in Cape Town and analyzes it as a case study. This brief introduction will be followed by a detailed look into the case study, including an overview, location of the site, the procurement of works, and a description of the works. The different SANS documents will be broken down and related to the project, where site clearance and earthworks will be discussed. These sections of the bills of quantities will be expanded upon in accordance with the outline of SANS 1200C and SANS 1200D, respectively. This project concerned here is Richmond Park. It will be developed as a mixed-use commercial precinct which will be split into three different sections, namely retail, commercial, and small industrial. This site is a greenfield site measuring approximately 14,258 square meters. Richmond Park is in a prime location and will be serviced by Cape Town's efficient MyCity rapid transport system, which runs along Tygerberg Valley Road. The park is situated in Cape Town and is about 1 kilometer from Boortesig. The park is plus minus 15 kilometers from the Cape Town CBD and very close to other industrial areas such as Montague Gardens. The position of the site allows easy access to the N7, N1 highway, Cape Town Port, and the Cape Town International Airport. The coordinates of the park are shown on the screen. Atterbury Property Development is the major shareholder in association with Old Mutual and local partners, Bethel Property and Cubic 3-Dimensional Property. Neil Liners and Associates were the consulting engineers who were appointed by the main shareholders to construct the roads connecting the different parts that make up the precinct. Companies have the option to either rent the land from Atterbury or buy it on a 99-year lease basis. When a company decides to purchase a plot of land in the precinct with the intention of constructing a building, a tender is sent out. Currently, Isipani is finishing up construction on one of the plots, and they have just been awarded a tender for another plot. This is mainly due to the fact that they still have plant material on site. Site clearance was conducted along the proposed road route. This site was previously occupied by squatters, which meant that the topsoil was not suitable for reuse and had to be carted off-site. Alien vegetation also had to be removed, as well as general waste. Boulders up to the size of 0.15 square meters also had to be removed. Earthworks were conducted on either side of the road for the purpose of installing drainage pipes, fiber optic cable, and water mains. To ensure that the road comprises of many layers, excavation had to be done to a certain depth. Layer by layer, different types of soils, each with different engineering properties, were rolled out and compressed to a certain compaction specification. Roads were constructed first to allow construction vehicles and other vehicles to access every part of the precinct. In fact, the municipality stipulates that roads are to be constructed before any work is to be done on a precinct like Richmond Park. This site is on a very flat piece of land, so not a lot of challenges were faced when constructing the road. I will continue with the section of the works, namely site clearance, as can be observed in the images on the slides. Richmond Park was full of undergrowth and closely growing shrub and vegetation that had been removed by the bulldozer shown in the image. In general practice, according to SANS 1200C, the following items are to be mentioned when clearing a site. Removal of topsoil taken to start at stockpile of site, removal of trees and other vegetation, such as shrubs, bushes, roots. Removal of boulders up to 0.15 meters cubed. Demolition and removal of existing structures. Conservation of protected trees, etc. Site clearance for Richmond Park includes the clearance for sewerage, clearance for external water, and the clearance for roads. In the process of works, site boundaries are established before clearance takes place. The topsoil and grubbing is to take place next, which is a vital component of the site clearance process, as this subsoil that is removed is not suitable for construction. Soil is to be removed up to a suitable strata is reached, usually up to 150 millimeters down. On our case study, we managed to obtain the site clearance builds for sewage piping, external water and roadworks. This site is flat and the existence of surface boulders and general obstructions were not present. This being said, not many clauses from the SANS documents were utilized for site clearance, but a direct comparison to the ones that were utilized will be made. In the slide provided, 8.2.1 Clear and Grub. The SANS document specified that this item of the work should be measured in meters or kilometers, but the bill we received of Richmond Park is measured in meters squared. The rate given is meant to cover the cost of transporting the material off-site to a dumping site located by the contractor. Clause 8.2.1 was used in this way for the external water and roadside clearance bill as well. Clause 8.2.8 present in the external water site clearance bill, demolish and remove structures. A provisional sum was given for the removal of an existing structure. There were illegal squatters on this site prior to this development. These buildings needed to be removed before the development could proceed. This is not as descriptive or detailed as a SANS document usually requires, but is stated in the bill as a description and a provisional sum. Clause 8.2.10 remove topsoil to nominal depth of 150 millimeters and stockpile. This clause is present in all three site clearance bills and is measured in a cubic meter. The bill rate includes the cost per cube of removing the soil either to a stockpile or further usage or taken to a dumping site located by the contractor. Clause 8.2.2 was analyzed on the roads site clearance bill. This is the removal of trees and were measured in units. There were 15 trees up to a girth of 2 meters that needed to be removed. Protected trees were replanted elsewhere.
Okay. Section D of the SANS 1200 documents deals with earthworks. This section has several subsections, including DA for small works, DB for trenches, DE for small earth dams, DK for gabions and pitching, DM for roads and subgrades, and DN for railways. Relevant to this project is only section DB and DM. Section DB of the SANS 1200 document deals with earthworks and particularly with trenches. Under this section, the bill measures the stockpiling, compacting, in situ material rehabilitating, as well as dewatering. No material from cutting was stockpiled as there was more filling than cutting, and the material from excavation was not suitable for filling. Imported materials was used instead to fill. The compacting necessary to make sure that before the imported material is added to the ground has been made to ensure that there's appropriate density. The ground conditions were poor due to the fact that the site was used for dumping, so it required some rehabilitation. And the dewatering was done to ensure that the water tables are drained out of the way. Okay, this was now an analysis of the earthworks section dealing with trenches. Clause 8.3.2 dealt with excavation for trenches, including backfilling, compacting, and the disposal of the surplus material. The bill measured the excavation for packworks in cubic meters, although there's an option to measure it in linear meters. It was measured in cubic meters. And to do that, the minimum base width for excavation was taken by adding to the diameter of the pipe twice the size allowance of the size of the actual pipe, and the dimensions are listed in the table provided under section 5.2 of the document. And the length used for the volume was the total through the length of the pipe, and there was no deductions for valves, manholes, and catch pits. The volume was then the total width multiplied by the length. Clause 8.3.3.1 was supposed to be referred to make up for the deficiency in backfill, but it was not mentioned in the bill. And clause 8.3.7, which deals with accommodation for traffic, was not mentioned at all, although we did notice that there was road signs used for traffic on site. It was not priced in the bill. And there was an additional dewatering item added to section 8.3.3, which is not found under the section 8.3.2 of the SANS document. A quick look at the portion of the BOQ in question shows how it was measured all in cubic meters, and there was an additional provisional sum added for dewatering, and there's no quantity for cutting to stockpile because the cut material was not suitable for filling, and there has been material imported from commercial sources for rehabilitation of the ground, which was in poor condition, and the volume to be imported was from other roads or other excavation on site and from commercial sources.
At SANS 1200 DM for the case study, which is roads and subgrades. The BOQ that was provided outlined the main clauses that has been worked on, that is the treatment of the road beds, cut to fill and borrow to fill, selected layers and compacted from stockpile, extra over for excavating and breaking down material, cut to spoil or stockpile from soft excavation, intermediate excavation, hard excavation, boulder excavation. For the treatment of materials, different materials that were brought in and compacted to a minimum of 90% density and 100% for sand. The descriptions were each categorized in numbers according to the road, sidewalks, taxi rank, etc. The item in clause 8.3.3 is according to the SANS DM document and was measured in meter cube. Same as clause 8.3.3, the clause 8.3.4 was measured according to the SANS DM document. Here, the clause in the BOQ distinguishes between material from stockpile and material from commercial source, whereas in the SANS DM document it is all in one, but still the unit of measurement is in meter cube as specified in the SANS DM document. Clause 8.3.6. This covers the additional cost of excavation in various materials, including breaking down of the material, and is measured in meter cube as in the SANS document. This clause covers the cost of excavating from the road prism in various classes of excavation as shown here on the slide, such as soft excavation, intermediate excavation, loading, transporting, offloading, and disposing of the material. The item was measured in meter cube as specified in the SANS document. Here, only material in excess of 55% of the loose volume of the layer on the road is measured in meter cube. Clause 8.3.13 was exceptional from what's written in the SANS document. Here, the only exception here is that a subsection C was added to the BOQ, which is not found in the SANS DM document. Here is an updated picture of the roadworks that's happening on the site. And here we have a picture of showing how the different layers that happen in the roadworks. Thank you.